Well, today what I would like to be doing is to build, to just get a couple of these microcontrollers to talk to a temperature sensor. And these are digital temperature sensors, and they're the kind that we're putting out in the temperature strings that we're using to measure how temperature varies with depth and upload it to the internet. So eventually we'll be building those kinds of sensors with the students. This is step one, just building the sensors without having the internet or the waterproof enclosure and all that kind of stuff. We'll do that next time.
We're gonna demo that with some like ice water and water at room temperature and things like that, and so you can log. We know what the ice water temperature should be, so that'll be a good test. And then we have some salt, so we're gonna dump some salt in there and then watch the temperature drop as the salt dissolves and makes it cool. So.
And this is very experimental.
Yeah, that's what it should be.
We haven't ever used these particular sensors before. So these are waterproof versions of the temperature sensors that are in here. They have this inside. And this is a little digital temperature sensor. And so we're all going to do this experiment together.
This thing costs, I think this one's $19 a piece. So pretty cheap, and they can do all kinds of crazy things. So this thing can probably do sort of the equivalent of like what your cell phone can do in terms of, it can't make calls or anything, but in terms of what it's able to do as a computer. And it's got a little USB connector, and so we're going to use it just to talk to some temperature sensors and to spit out the temperature and print that to the computer. You can program them to do all kinds of things. So that's why we really like them, because they're at sort of $19. If we screw up and we break one, it's not a big deal. But you can make sort of a cheap sensor out of this that can do this platform can be used for lots of different things.
The sensors that we're going to build are really the kind of sensors that we use in our own science. So when you guys put out sensors, then we can use the data, and those will be useful, hopefully to you, but also to us. We're going to sort of show you a little bit about how this works. Hopefully we'll get as far as taking some temperature measurements and having these things function, and then however far we get, we'll take it up next time, and we'll build sensors that we put in housings, PVC housings or something, and you guys will take them out into the environment. Let me just show you the kind of things that we can do. I just want to show you a bunch of sensors and a bunch of the capabilities that these little microprocessors have. So these are the microprocessors that we work with. They're called Teensies. Pass that around. Just a little tiny computer, and it takes electrical signals in and puts other electrical signals out. And so all the things that we're doing are ways of manipulating that. So to begin with, one of the useful things to be able to do is to turn stuff on and off. So these are teeny little microcontrollers. They put out very faint signals. So there are a number of ways that we can turn things on or off with them. They're too small to, say, drive an electric motor or a heater or something, but they can power a switch that is driving it, that is controlling something that has a lot of power. So this is an example of a switch that is called a relay, and this little microcontroller can turn on and off this big switch, and this big switch can drive something big like a heater or electric motor or refrigerator or something. So when you have a stove at home that you set a temperature to and it goes up to that, it has something like this inside of it, and it's turning off and on. So that's called a relay. Okay, so here is my example of this Teensy, and what I'd like you to do is to put that into the breadboard. And the way that it works is you put it down on top. It's kind of pretty, more or less the way that it seems. You put it down and the pins have a little bit of friction, then you press it down. Okay, so what you can see is that I put it all the way, so this end, this is where the USB cable goes in, and it's all the way over there, because that gives us a few empty holes down at the bottom of the plate. But the idea here is that this whole row is connected. So there's a pin here, and we want to be able to feed electricity into it, or take electricity out of it, and that means we can stick a wire here, here, or here, and it's connected. But it's not connected up and down. So if we want to connect this row to this row, we have to run a wire all the way down from there to there. We need to figure out how we're going to work with these sensors. The way we're going to work with them is using these computers and some software that's made by an organization called Arduino.
So this light is blinking right now, but that's not what this chip has to do. That's just what the program on here is telling it to do. But if I load a different program by clicking in this program, I'm going to show you guys how to do it. I'm going to change the program on here, and then the light's going to stop blinking.
So you give me like a new brain or like any brain?
Yeah, no, that's exactly right. So I just rebooted it, and now it stopped blinking.
So again, I've never used these, but I think that what's true is that the black is ground, meaning that has 0 voltage, and the red is where the wire that supplies power to the sensor. So that one wants to have 3 volts going into it, and the other one is the signal. So we have these 3 wires, and they have a little bit of bare end. And what we're going to do is to put the ends of these wires into separate rows at the bottom of the breadboard. So there's the bottom of my breadboard, and I have one wire, 2 wires, 3 wires. So here it is, under the camera. So what you want to do is look something like that.
We should get this thing powered to a battery and put the screen on it so you can see that stuff on here. Melt all the ice. Melt all the ice. What do you get down to, like 26?
So you're doing the temperature?
Yeah, it's right there. 29, 41, 29, 41, 29, 19, 29, 19, 29, 20.
Wow, you guys succeeded.